Hello, good morning to all of you. So I have to talk here about why is this book important and what is the necessity of this book to come into picture. So let's just start with the introduction to the author. Myself, Amit Keshav. I'm working as Associate Professor, Department of Chemical Engineering, National Institute of Technology, Raipur. And also I'm the Associate Dean, Faculty Welfare, Professor in Charge, Institute Library, the admin for the online course Coursera, and the coordinators of one of the coordinator of the audiovisual committee about the classroom improvement of the institute, as well as I am the accreditation in charge of the Department of Chemical Engineering. So I have a total work experience of 14 years, out of which 11 years had been from this institute, NIT Raipur. At NIT Raipur, I have been engaged mostly in teaching the subject transfer phenomena for these 11 years, as well as numerical methods, computational fluid dynamics, advanced transfer phenomena, and process intensification in chemical engineering. Prior to that, in my earlier institute, I had been involved in the subjects like process modeling and simulation, chemical reaction engineering, mass transfer, fluid flow, and thermodynamics. So on overall, I have taught almost most of the basic core subjects of chemical engineering in my total period of teaching. And what I have been thinking about is that like we are taught the basics of engineering, or we can say basically the basics of chemical engineering through the teaching of the subjects like heat transfer, mass transfer, chemical reaction engineering, thermodynamics, the essential subjects like physics, chemistry, and maths, along with the elective parts, which is the advanced topics basically, which are the advanced topics, and fluid mechanics and design. So these core subjects are going to build up the stem of engineering. So the main thing is, like if you see from this particular tree, there is no leaves and there is no fruit. So basically learning the basics of engineering is essential to build up the stem, because that defines your strength of doing something, but it does not relate to the application field. So the better the stem, it's okay, fine, you are good in basics, but how about application? Let me give you an example. This is an example which have been posed against me when I have joined one of my job, where they asked me to just design a system in which they needs to make a paste which is thick as a toothpaste, to make it flow from the ground floor to the first floor with the help of a pump and a pipeline. And the later on, this particular fluid have to be spread and form in the made to be formed in form of a sheet through an application of heat and as well as the vibration, so that there's a particular spreading of that material on the, you can say, screen. So this overall process need to be designed. So now the question is that do that basic knowledge allow me to design this particular process? The straightforward answer is no. And there are options for you as a student. If you can go and find out, are you able to design this particular process? I will definitely agree with, or you will definitely agree with my statement that it's just no, because with the knowledge of basics, you cannot go in designing of a process. So what is the requirement of a thing is that basically this tree is incomplete due to the application part, which is missing. Mostly, most of these colleges used to teach these application parts in either the last semester, where the students are more busy in doing the searching for the jobs or doing the other gate exams and CAT exams, and so they generally miss out these things. We call them as elective somehow, but these type of course application based subjects, where the basic knowledge which you have learned through the period is going to be applied, has to be in the starting. So there is one subject out of these all subjects which you can link out, is like in this particular sheet we can see that there are all those common core subjects as a root. We can see fluid mechanics, we can say fluid mass transfer, physics, maths, chemistry, heat transfer, numerical methods, and all the basic electives which are essential to give you a knowledge to build up the STEM. But before the STEM, these all merge into one subject. That subject is transfer phenomena. So if we know transfer phenomena entirely or completely, then we are very obvious that we know the core subjects too, because they are the requirements or the prerequisite for this particular subject. So all the subjects go into transfer phenomena, and that is going to make up the stem. And then that stem is now having leaf. This particular tree is having leaf. This is having fruit. And what are the leaves and the fruits are the application part. The application is the applied thing. So we can say it's called applied knowledge. And that applied knowledge is essential for research. That applied knowledge is essential for doing the design and numerical experiments, because transfer phenomena allow you do an numerical experiment. And also modeling simulation, which is one of the subject which is generally taught in the 8th semester, is the extended subject of transfer phenomena in a different way. So most of the books, if you can compare, you can go back and see that most of the books are relative. They are actually linked to transfer phenomena. You can do the same problem which you're doing in modeling and simulation by transfer phenomena. Exact thing is a little step ahead, because you need now a programming, and you need to learn about MATLAB, C language, or any Pascal, or whatever the language are there. You have to learn those languages to do simulation, right? So transfer phenomena, a step ahead, goes to process modeling simulation, and a one step ahead goes to computational fluid dynamics. So if you have a core knowledge of transfer phenomena, then you are having a core knowledge of application of those knowledges which are becoming the basics for engineering.